Now in this question we want to minimize x plus y. We don't want to minimize x or minimize y, we want to minimize the sum of them. So it's a little bit of a lengthy solution, so I'll try to give you a screenshot here before going further into it. Okay, now looking at this, we see that if we let this value here be a, then this other segment is 12 minus a, since the whole thing is 12. Now we have a right angle triangle, 3 and a, so this hypotenuse is going to be the square root of 3 squared plus a squared, or in other words a squared plus 9 quantity to the 1/2. We have another right angle here, 12 minus a and 5. So the square root of the squares of the sum of the squares of those sides is going to be a squared minus 24a plus 169 quantity to the 1/2. And the domain, in this case our independent variable is a, the domain is going to be 0 to 12. So the distance of x plus y, the distance as a function of a, is going to be this quantity plus this quantity. Setting this derivative equal to 0 means that 1/2 times a squared plus 9 to the negative 1/2 times 2a, the derivative of what's inside, plus 1/2 times this quadratic expression to the negative 1/2 times the derivative of what's inside, which is 2a minus 24, equals 0, is solving this for a will give us a value of a that's significant in this case. Well, what we're going to do is keep everything here on one side. 2a times 1 is the numerator. A squared plus 9 to the positive 1/2 is the denominator, along with the 2. And over on the other side, if we subtract this entire term, 1 times 2a minus 24 is 2a minus 24, so we put a negative sign in front of that since we're subtracting it, and the denominator is a squared minus 24a plus 169 to the positive 1/2, but again times 2, of course. Distributing that negative sign in here gives negative 2a plus 24, which is the same as 24 minus 2a. But keep in mind, if we have 24 minus 2a in the numerator and 2 in the denominator, we can divide through by 2, and we're left with 12 minus a in the numerator, and our denominator is the square root of that expression shown. Similarly, dividing by 2 over here gives us this expression. And it might look complicated, but it's really not. Now, at this point, since these are equal to each other, and since a is positive, we know that we can square both sides. So a squared, the square root squared is simply the expression. 12 minus a quantity squared is given. The square root squared is simply that expression. Now, what that leaves us with is, after expanding out that numerator, we get this expression here. What we can now do is multiply both sides by each denominator, giving us this expression here. Expanding it out gives us this massive quartic equation. But believe it or not, it simplifies down to become a quadratic because the a to the 4's cancel out, as do the a to the 3 terms. And what we end up with is, again, remember we're setting this equal to 0. 8 times this quadratic equals 0. We know 8 doesn't equal 0, so this expression must have to equal 0. Using the quadratic formula gives us a is 4.5 or negative 18. But we said a while ago that the domain of a is between 0 and 12, so we know that a has to be 4.5. Using determining the distance total using our endpoints of 0 and 12, we get values of 16 and approximately 17.4. But in between, using that value of 4.5 for a that we got from setting the derivative equal to 0 and solving for a, we get a total distance of approximately 14.4. So that's the minimum value of x plus y. Now, believe it or not, we could have actually done the whole question a lot simpler if we realized that the shortest distance is going to result in the shortest distance total is going to result in similar triangles. So 3 plus 5 is 8. If you take this 12, this base that's 12 units long, and divide it into 8 equal parts, each one of those parts would be 1.5. So 3 of those 1.5s will be out to here. So in other words, A will be 3 times 1.5, which is 4.5. And 5 of those 1.5 unit parts will be this part here, which means this part would be 7.5. So we could have done it by observation, realizing A had to be 4.5 to keep these triangles similar, and then just simply done 2 different Pythagorean theorems and added the totals.